Hello, my name is Grant Fritchey. I work for Redgate Software. Let's talk about the Health Insurance Portability and Accountability Act, HIPAA. Article 2 of HIPAA has this thing called the privacy rule. And the privacy rule is very simple to understand in concept, if not crazy difficult to implement. And the idea here is that there's stuff that is PHI, personal health information, basically, diagnosis, I'm a little overweight, that kind of stuff, or billing information. I'm spending this much money on my health care. This is all considered PHI, private. So another core concept of HIPAA is that this private information should be exposed in the least possible fashion. So it's okay that the doctor sees things. It's okay that people who are approved in your family see things. It's okay that certain types of data processing is going to occur inside of production environments, and so some data is going to transfer from one place to another, and that's all acceptable within HIPAA. Great. But your development team is not on the approved list and can't be because least access. You don't just say, well, our, quote, least access is everybody. No, it doesn't work like that. You actually are going to have to limit who gets access to what, which means when you start provisioning non-production environments, you're going to have to put data together in a way that you mask off information that's not, acceptable in these non-production environments. Redgate Software is here to help. We have SQL Data Masker, it's one of our tools, and it can do a whole bunch of stuff for you. What I'm going to show you today is actually a customized method that you can use to mask data that will allow you to correlate one column to another through your own defined lookup list, so you can create something that looks like production data. Let's go check it out. So I just want to start off here in Azure Data Studio to show you a database that I'm working on. It's called Patient Information. You can see it over here on the left. Specifically, what I've got is a person table, and the person table has some columns that we're going to mask: first name, last name, date of birth. We've also got some other tables that we're masking, but the big one that we're going to focus on right here is diagnosis. Now, this data is not properly normalized. I would want to actually redesign this database if I had the opportunity, but for our purposes, we're going to use this database as is and talk about the mechanisms within it and how to mask this information so that we capture diagnosis and treatment data that looks real even though it is not. This is Data Masker. And so what we're doing here is very simple. If we look at the person substitution rule, it is taking the first name and replacing it with a distribution of male and female first names. And yeah, you can figure out how you want that done. And then we've got a distribution of surnames, just random from a large list. And then dates, randomly distributed with a start and stop time, 1930 to 2007, but you can set it any way you want to. And that's, all very easy to understand. We're masking the person's information. Now, the diagnosis information is a little different. So what I've done is I've done two things. First, I went to a government website and found a common chronic illness list. And I got a distinct list of common chronic illnesses. And then I used that list to create a custom substitution rule. Now, in this case, the custom substitution rule is called diagnosis and treatment, and I've got two columns. I've got diagnosis defined as field 1, and then I've got treatment defined as field 2. Here, I've got my built-in data sets for all the different kinds of data masking I can do. And if we go down to the bottom, because I've got them sorted by type, we can see that there's a couple of examples, endangered mammals, UDEF, and country names and ISO codes, UDEFC, and it's the UDEFC that I'm using here, and it's a very simple mechanism. I provide, in column 1, I provide the information that I care about for the diagnosis, and in column 2, I provide the information I care about for the treatment. And you can mix and match these in different ways, and certainly there's a whole bunch more complicated in examples I could put together, but for our purposes, I just want a simple example of, here's the diagnosis, here's the treatment. I would like them always to be correlated, even as what we're doing within our substitution rule is scrambling them. So let's see it run. Cancel and run masking set. Yes, run the rules. And we can watch the rule statistics and see things as they occur. All right, and there it's complete. Now, let's go back over to here and let's run a query. Can we run it through this? Yeah, we can. Great. Oh, no, I don't want patient info. I'm sorry, I want diagnosis, don't I? Hit run, query starts, the results come back, and you can see that these things are lining up exactly. So if we find, if you remember, my recommendation for if you have alcohol as a chronic illness is to stop drinking. So those lined up exactly with the defined fields, and they would always line up that way. So any way that you want to correlate these things, you can correlate them across for multiple columns, up to 8 different columns, and it's completely customizable by you any way you need it to work. As you can see, there's a lot of flexibility built into the tool. So there's different ways you can get things done in order to arrive at a place where you're delivering, as much realistic, almost production, but not quite production, data as possible. So that's it. Thanks a lot. Please follow the links down below. Subscribe. I've got more information coming on this stuff, redgate software, query tuning, all kinds of fun things. And you don't want to miss out, so make sure you subscribe. My name is Grant Fritchey. I work for Redgate Software.